Thanks for coming for our session. For me, it's a pleasure to be here and have the opportunity to share this amazing success case from AXS, and developed from our partner BPlus from Brazil. Cezar from AXS will present the business case, and Henry from BPlus will present the technical challenge to develop this amazing case. In the end, my colleague Benjamin will present some news about experiences for develop AI apps. Thanks. Cezar, please.
Hello, everyone.
Hello.
Good afternoon. I am Cezar Azevedo from AXS Energia in Brazil. Today, I want to share a story that's behind technology. And a story about what happens that goes use intelligence, artificial intelligence, and they use it to resolve problems about the complex. And it's also a story about how AI connected to real business needs can move from the hype to a measurable impact. This is a story of how we start building the intelligence layer behind the clean energy. Clean energy is not truly if the axes remain complex. At some point, the challenge is no longer only generation. It becomes a coordination, prediction, and becomes true. And ultimately, it's become a decisions. That is right when clean energy becomes a data problem, most companies break. This is an image from a farm, an energy farm in Brazil. And it's very amazing to see this picture because when you see the solar grids here, you don't imagine how many sensors have in this place. Have millions of sensors, of IoT sensors here. I cannot imagine how much sensors, but probably for each panel have one IoT sensor in there. And about these sensors, you need to think about the complexity. And the complexity does not scale linearity. It spawns scientificity and across operation, maintenance, revenue, forecasting, assets, performance, and the customer experience. And the more you grow, the less visible the complexity becomes at the first. Think about how many plants you need to manage with many data. One day, it starts slowly, and decisions is going to be for everywhere. At the AXS is not abstract. We operate a scale that forces a decisions to scale as well. More than 50,000 customers. It's not so much, I know, but for this market, you have an amazing quantity of customers. We have 2.1 billion of the reais deployed in money. The assets is very expensive. And 150 megawatts peak. 350 megawatts peak to generate energy. And that level, the conversation stops being only about assets, very expensive assets. 2 billion of reais is too much money. Probably here in Brazil, you cannot imagine how much money is this you have. it becomes about how to operate predictive and decide across the dynamics and rolling system. Well, this is exactly how our CEO, Rodolfo Pinto, sees the opportunity ahead. Brazilian energy transition is not only about generation. It's about access, it's about experience, and about intelligence decisions. More than 200 million of the Brazilians will change the way they consume energy. 200 million of Brazilians gonna be change the way to use the energy, the solar energy, or the sustainability energy. And our role is to help connect them to that transformation. It's a mission, a proposal. I think it's a very nice place to work, guys, because we create impact in the life of the people. It's amazing. And this presentation is not about energy. It's become about decisions. We just talk about decisions. And when you have more plants, more customers, more variabilities, and more pressure on operations. And once that happens, the real question becomes to make better decisions at scale. The scale is very important for us because you don't think about one plant. We talk about 130 plants. And in Brazil, this discussion is very concrete. Energy is not abstract question or not abstract infrastructure topic. For a small business, is a margins. For a family, is a predictability. And for operation, is a pressure. The operation is very hard to work in these plants, guys. And in this context in which AXS was built, we do not see ourselves like a solar company. We see ourselves as an energy tech. What's an energy tech? It's a company where energy, data, and decisions work in one system together. Have you mean about the energy tech sometime? Fintechs, probably, right? Energy tech is the same for the fintechs or the Netflix or the deliveries foods. Have a food here? No. Uber, like a Uber. The energy tech is the same for the Uber for the energy. That's it. And the moment you decide to scale this model, everything happens at the same time. You have problems with generation, operation, performance, forecast, maintenance, assets, very expensive assets, revenue, weather. Think about the weather. When you have the bad weather or the baddest kind of sun, oh, the sun is not the same in any place. I don't know if you think about this, but a country like Brazil, the weather is very important for us. But for the energy, if the weather is so hot, the quality of the generation is not so good. It's amazing think about this. And when you understand something very important, to scale access the clean energy, having access is not enough. Having a software has not enough. There is no longer only a solar problem. It becomes an intelligence problem. How do you solve the intelligence problem? How unify data? How you create a contest. How will enable decisions? How will sound? That sounds simple, but in practical, it requires architecture, governance, trust, and operational discipline. That is the path that lead us to Orion. I don't like this name, guys, to tell the truth. But after the Artemis, my friend, and he say, hey, Orion is not so bad. Okay, I don't like Orion, okay? A little note, I don't choose this name, okay? But okay. But Orion was not built just another chatbot. It is built to transform fragmented operational data into decision intelligence. Powered by InterSystems. I'm so glad to use InterSystems for this. You don't imagine. If not, I say all the time, and I don't find a job in InterSystems. Not yet. But really, Benjamin, I say all the time, if InterSystems don't be used and the AXS, the company is not, it's possible. It's not possible. And all the time I say this, hey, it's possible. Yes. The another guys, for another companies use a different kind of service is a problem. 1 minute, okay. Henry, is your time. But to show the hype, to real impact, I invite you, Henry, to explain about this. Thank you.
Hello, everyone. Thank you, Cezar. So I'm Henry. I'm a technical leader and innovation specialist at BPlus. And since 2003, BPlus has been InterSystems partner in Brazil. And our mission has always been simple, turning data into decisions and decisions into results. And over the years, we have the privilege of building the digital nervous systems that support leaders across nearly every critical industry. And at BPlus, we are now advancing a new wave of innovation. I'm part and head of this, and I'm really proud to say that this project with AXS is already one of our major success. This strong partnership with AXS helping to generate the clean energy of our future, as Cezar just showed us. Right now, we are living through a new gold rush, but instead of gold, everyone wants to put AI into their product. Every board of directors is asking for it. Every developer is trying to build it. But when a team rush to implement AI just to check a box, they often discover a very different kind of AI, anxiety and insomnia. We didn't want that for our team, and it's certainly not for our power grid. And today I want to share you the journey of Orion and how we avoid this hype of AI, stop fighting with our data, and build real, measurable intelligence by combining AI with the fundamental laws of physics. The dream for Orion was beautiful. We want a solar plant operator, regardless the technical background, to just ask questions in natural language, instantly get operational insight. But to do that, we had to open the hood, and we expect to find a crystal clear, modern data lake, but instead, we got a data swamp. For engineers here, you know exactly what a data swamp smells like. It's not just technical, but it's cultural fragmentation. We had departments acting as gatekeepers, and our senior engineer was wasting weeks doing archaeology to understand the data. And when we finally found the data, we hit another boss, a lack of standards. We had the exact same solar plant registered under 3 different names, and Human knows exactly that it's 3 solar plants, but an AI, it hallucinates. And people think AI is magic. Just do a prompt and you solve that. But to do that, in our case, to build an AI on a data swamp, it's like you asking for 3 master chefs to bake a one world-class cake, and they are locked in separate kitchens and don't speak the same language. Doesn't matter how expensive is your AI, the cake will be a disaster. So we cannot build this, and that's when our partnership between AXS, BPlus, and InterSystems truly began. We didn't just use the technology to move data. We use InterSystems to break down all the silos, organize the calls, and build a crystal clear, unified data fabric. Only then, when we establish our 4 pillars of intelligence. First was descriptive analysis, consolidate performance views into a single source of truth. The second one was relational analysis, connecting information across different databases. Predictive analysis, anticipating problems. And diagnostic analysis, pinpoint failures and production drops with our 4 pillars defined. Sorry, but I'm Brazilian. My English is chaos, and my accent is strong. So with our 4 pillars defined, we built the very first versions of Orion. And for our technology stack, we use InterSystems IRIS as our core engine. Seamless integration with LangChain directly through embedded Python. We use the language Python for the first version. We thought the hard part was over. The data was clean. The stack was solid. It was just time to magic. So we gathered all the team, and like I said, the dream was just asking Orion anything, so we did. And the Orion, the first version, responded beautiful, but very, very wrong. We hit the wall of hallucination. And if an AI tells the operator to shut down an inverter based on a hallucinate anomaly, we lose megawatts, we lose money. So we did what any good engineer team does. We tried to put guardrails on it. We gave a lot of rules, but soon it was like to try explain to the AI an entire manual of a power plant in a single conversation. The prompt became huge. And let's be honest, what is the first instinct of a developer when a prompt fails? You add more prompt, of course. So we had a lot of conversations with InterSystems. Fernando and Benjamin's support was crucial here. We realized our fundamental mistake. We are treating AI like an all-knowing oracle. And worse, we are flying blind. To fix all the hallucinations, we had to open the black box, and we implement tracing with Langsmith, and it showed us the ugly truth. Our prompt was inflation and destroying our accuracy and our budget. And to answer a single and simple question, we were sending a massive 500 lines static prompt. A lot of crazy math and SQL rules. So we need to radical prompt reduction. So instead of sending a massive wall of text, we broke those rules down. We vectorized our prompt. All the instructions we vectorize and store in embeds inside InterSystems IRIS using the vector data type. So we create a dynamic assembly line. Now, when a user asks a question, we perform a lightning-fast vector search and against our system's rules. So we create all the prompt dynamically and retrieve only the specific instructions and the context needed for that exact intent. And we assemble a surgical high-focus prompt on the fly. But we didn't stop only at dynamic prompts. We changed our entire architecture. We stopped relying on a single brain and built a multi-agent architecture. The first thing we built was a gatekeeper, a triage phase. Before the AI even tries to touch our data lake, this gatekeeper intercepts the prompt. The only job is understand the user intent. This is a valid operational question, or the user asking for a cake recipe. Or worse, is it a prompt injection attacking and trying to manipulate our systems? So if it is off-topic, ambiguous, or malicious, the gatekeeper drops it immediately or asks for more clarifications. No wasting process, no risks, no hallucinations. If it is a valid question, the gatekeeper acts as a dispatcher. Remember the 4 pillars of intelligence I mentioned earlier? The second pillar was relational analysis, connecting different realities. To achieve this, we split the Orion's analytical brain into 2 distinct hemispheres. First, we have our ground-level agents. They look exclusive at the machines down on the ground. They captured and standardize the telemetry across different inverters manufacturers, tracking the actual generation and the real-time performance of the hardware. Then we have the meteorological agent. It only looks at the sky, satellite meteorology, expected radiation, and weather conditions. When an operator asks a complex question, for example, comparing the plant actually generated versus what the weather said it should generate, the orchestrator routes the question to both agents in parallel. They each retrieve their highly specific context of their jobs, and a synthetic agent stitch the truth together. We move from tell the AI everything to give specialized agents a target mission. The results were immediate. Hallucination dropped to almost 0. And most important, trust was established. So, with Orion's successfully diagnosed the present, we move to our next and hardest challenge, prediction. We were trying to predict energy generation based on what the weather might do tomorrow. In other words, we are trying to predict the unpredictable. Because why make our engineer's life easier? Come on. We start our machine learning journey using PMML, standard natively inside InterSystems IRIS. And for our first attempt, it was a general linear regression model that we used. We threw everything into that. 24 different parameters, including years of noisy data. The result, a complete disaster. On our first day, we had an absolute error nearly for 15%. Why did it fail? Because a simple linear equation cannot comprehend the chaos of nature. So we pivoted the art of subtraction and cleaned all the parameters, cutting for only 7 essential features. By removing this excess, our error rate dropped significantly. So to handle those nonlinear relationships, we needed robust algorithms. Standard PMML couldn't do that. So we built a hybrid execution architecture. We stopped moving data around and brought the models to data. Run embed Python natively inside InterSystems IRIS using %cs.python. We train and compare machine learning models like XGBoost, LightGBM, and random forest side by side. When we evaluate them against a completely unseen test data, random forest proved, Just a second. Okay. Sorry. So the random forest proved incredibly robust, giving us the stable engine we need. So we finally has a world-class model, but then we hit another wall, the cold start. Because to match our random forest model demand years of clean data historical data. So how to train an AI to predict a future of a power plant with no past? So last year, I was invited as an InterSystems mentor in MIT hackathon on Albert Einstein Hospital in Brazil. And during the first lecture, a cardiologist was explaining how a digital twin of a human heart fills information gaps by generating synthetic data, a technique borrowed from the engineer and applied into medicine. I had never seen that before, and suddenly I realized, oh, that is exactly the cure for our cold start problem. So I take from medicine and implement on engineer again. And we discovered that pure data science wasn't enough. We need physics. We built a deterministic digital twin natively inside InterSystems IRIS using embedded Python and a PVlib. We weren't guessing anymore. We are mathematically simulating the plant. But translating physical reality into code was never easy, especially for me, because let's be honest, I'm terrible at physics. So we faced 3 brutal engineer lessons. The first was the geographic trap. All the global data sets often default to panels facing south. But in Brazil, we must face north. If we blindly trust on the metadata, our AI would predict a catastrophic energy drop simply because it was looking for the wrong sun. Second, the heat trap. Because of tiny information mismatch in how we store the panels, thermal efficiency automatically completely explode. And the result, our simulation confidently predict absolute zero energy generation right at the peak of the midday sun. And then finally, the sunlight puzzle. Instead of relying on expensive weather sensor to measure direct versus diffused light, we use and apply physics to split the sunlight mathematically, running our twin perfectly even with a scarce climate data. Thank you very much. Obrigado. When we finally fixed the geometry, the heat, the light, we turn the engine on. We test our digital twins against 28 days of real data that was used to train. And the first day we hit this 81% of accuracy. We completely bypassed the cold start problem. And we didn't need to wait years to train our AI. When the data didn't exist, we used the laws of physics to write the history ourselves. Actions speak louder than words. This is Orion works. They should work. I record a video just to work. Come on. Oh, now, what's the generation of power grid? They on a specific solar plant in February 2006. They start to think. This is our response for operator. All insights of this data generation. What is the project generation capacity for another power plant? They are thinking now. And they give all this report with 34 days forecast of the power plant, and how they generate in first the linear regression, and after with comparing the results of predictive with the random forest algorithm. Here is the random forest. And after that, for the operation, they summarize and put the difference between the two models. So they compare. This for the operation, the comparison of the two models and two predictions. We did that to the operation didn't blindly trust in predicting in our predictions. Then they use this to decide what is the better. So none of this would be reality without an incredible team. I want to thank you here, AXS and Cezar, for believing in us, and the whole BPlus family for this opportunity, especially our director, Leandro Keller, who is just here. I want to ask a round of applause to him, if possible. Thank you. Will make my salary negotiation much easier tomorrow. Thank you.
Okay, great. First, this story is not about a prototype. It's in production. It's very important for us. It's a beginning of the new operational model for energy intelligence. And the impact is measurable. And in our case, this initiative delivery, this number is correct. It's a 98 right now. The prediction is changed every month. Every month, when you check the information about the prediction, and you check the information about what Orion is predicting, is increased every month. It's not so cheaper, guys. I know. It's very expensive. Running AI is not cheaper. Finish. But it's not a vanished metrics, okay? It's reflect a better planning, better efficiency, better service, and it's the future, I think, I believe. There is a big point here. The future of the clean energy is not one generation. The intelligence decisions, it is the intelligence decisions making. What matters is not one production more energy. What matters is making the system around that energy more adaptive, more predictive, and more trusted. And let me close with a simple version of the story. The question is no longer only how do we generate energy. The question is how do we make better decisions? That is the shift. Okay. And thank you so much for your time. And before we close, I want to recognize the partnership between AXS and BPlus with my dear colleague, Leandro, Henry, André, Marcelo, the engineers from AXS, Araxá, Valdemar, Alison for being proud to increase in this project, is the general manager. And I'm very happy to have a conversation after the session. Have you something to show? Okay, thank you guys.
Well, thank you very much, Cezar. Thank you very much, Cezar and Henry, for letting me steal 5 minutes of your session to give a little bit of context about what we're doing with InterSystems in this area. And I think I got some undue credit about the conversations we've had, because I've been mostly asking questions rather than giving you answers. Because what I'll be talking about is the AI Hub, which we'll comment on or describe in much more detail tomorrow during the keynote and later in the day. It's a new capability for IRIS that's been under development while you guys were already well onto your project. So we've learned a lot from their experiences and try to use that, take that into account in the design and priorities that we set with the hub. So with that, what is this all about? Why do we build the AI Hub? What can we do in the world of AI? So AI is all about the context. It's that business context that Cezar was talking about. And I'll use a very silly analogy. If you're looking at a chart that has just a line like that, that's completely useless if you don't know what the x-axis and the y-axis are. That's because the context is lacking. You'll say, Benjamin, that's a really silly analogy. But if you think about ChatGPT, that's generative AI. It's kind of generating text, and that text might look okay, but if it doesn't have context, if it can answer you questions about what is a nice restaurant in Washington. Maybe it's helpful if you're in the business of writing trivia games, but for true enterprises, okay, trivia games might be a proper enterprise, but in a true enterprise, that's not helpful. It only becomes helpful when you add context to it. So that's what we're trying to do with the AI Hub, making it easy for you to add context. That's what we're trying to do with IRIS as a whole. So if you're developing an AI application, we're trying to make it easy for you to add knowledge that is specific to your enterprise, that is specific to your organization, documents that ChatGPT has no access to, or records that are in your database that you also don't want to upload to an online service. And also make it easy for the AI app to grow into something agentic, something that can change the world around it by invoking tools. So we'll talk more about that tomorrow. But I just wanted to kind of briefly sketch what the AI Hub is. So the AI Hub is new infrastructure for InterSystems IRIS that comes with 3 new capabilities. First, we help you build native agents on IRIS. So if you're an object script developer, we're giving you new paradigms or new concepts that are simple abstractions of a language model, of an instruction, of a tool, and you can combine all of those into agents that run natively in IRIS. And if, like BPlus, if you're developing with LangChain, we also got you covered because we connect the LangChain concepts to what you would store in IRIS and make sure that the governance that IRIS offers, the security model, the access control, the auditing, that is all incorporated also when you're using LangChain. So that's why LangChain jumped the line, and based on the feedback that we got from you, we also made sure that that's available now in the early access program that starts today. Native MCP interoperability. The Model Context Protocol is just as the name says. It offers context to models. It is a protocol, like it's a little bit like a mix of REST, HTTP, TCP, IP, whatever, all kinds of. It crosses some boundaries in the networking stack. But what MCP does, it allows an AI to talk to business logic, talk to data, give that knowledge, give those tools, make those exposable to your AI. So we've got that implemented natively for both inbound and outbound connections. And then finally, operationalize AI with IRIS. Embed AI into your workflows, because an AI app that sits there in isolation is nice, but if you can embed it in your workflows, in your business processes, that makes it all the more valuable. And make sure that there's a human in the loop. And that's not just somebody who sits and presses yes when ChatGPT asks you to confirm to execute a particular action, but that could be someone sitting thousands of miles away who happens to be at that place in the approval workflow. So just finally to summarize, why did we build the enterprise? Why did we build the AI Hub? To make it easy for you to add enterprise context. Make sure that the AI gets access to the knowledge and the tools, the data and the tools that are relevant to your application. We want to make sure that the AI that you run runs in the right security context, that it kind of is controlled, access is controlled in a central place using the identities and the policies that you already have in your application because it's running on IRIS. And then finally, that integration that I just mentioned with human workflows, making sure that you can easily implement hybrid flows that incorporate both agentic action and human approval. That's what we're delivering with the AI Hub, which is available as of today as part of an early access program. So in that program, you'll find documentation, you'll find access to the kits. Actually, yesterday during the hackathon, the pre-conference hackathon, there were already a lot of teams from various customers and partners that put their hands on it, and it was really exciting to see what they were able to pull off in just a couple hours. So that's all I wanted to say. So again, a big thank you for Cezar and Henry for bringing us such a beautiful story, and for letting me steal a couple minutes.
Okay.
Actual work.
Tomara que não. Yes.
I think we got time for 1 or 2 questions. But anyway, all of us are around here, so we'll be happy to field your questions if you have any.
So we vectorize all the structure of our tables, our data lake, and when we use the generative AI to create the queries to use on the data. On the data lake. On the data lake, yeah. Yeah.
All right, well, thanks again, and hope to see you.
Okay.
Hope you enjoy the rest of the conference.
Thanks.